A bridge collapses, and we blame a weak piece of steel. But the part that snaps is rarely the whole story. Designers, builders, inspectors, budgets, and maintenance form the real system. Failures hide in links we do not notice. And one link is missing more often than you think. Redundancy. Redundancy is spare capacity. Backups that carry the load when something fails. Yet many systems are engineered with single points of failure. In the next few minutes, we will uncover why redundancy is rarely built in. Costs, complexity, rules, slow risks, overconfidence, a real blackout, and the one lesson that changes design. We know backups work. Spare tires, twin engines, mirrored servers. Still, incentives, thresholds, and delays nudge organizations to remove slack and call it efficiency. This is a documentary about what happens when things go wrong and how hidden mechanisms turn small errors into system-wide consequences. First, redundancy costs money, a visible cost managers must defend today. A second factory could cover fires or floods, but it is expensive to build and keep ready. It needs power, staff, maintenance, and security, even when it produces nothing. The cost is certain and immediate. The payoff is uncertain and in the future. It might happen next year, in a decade, or never. Short-term metrics reward cutting backups, not preparing for rare shocks. Lean systems remove slack, inventory people capacity to boost efficiency. But when slack vanishes, redundancy vanishes with it. Everything works, until it does not. High utilization amplifies small disruptions. The drive for efficiency competes directly with the need for resilience. So, why do some backups make leaders nervous, even when they add safety? Because adding redundancy can add complexity and new failure modes. Cost explains a lot. It does not explain everything. Which costs are hidden in your industry? Keep this in mind. Removing apparent waste sometimes removes the only buffer you had. Next, the paradox. When backups themselves introduce new ways to fail. If you find this analysis useful, tap like, drop a quick comment with a system you want us to map, and subscribe for future System Atlas breakdowns. Second, adding redundancy can make systems more complex. Complexity needs switches, sensors, and software to coordinate backups. Each layer adds new failure points: a stuck switch, a bad sensor, a software bug. Simplicity is easier to operate, maintain, and train. Do you accept a clear single-point risk or diffuse harder-to-predict risks? Fear of complexity often wins and redundancy is reduced. More complex backups require more training and practice under stress. Without it, people can activate a backup at the wrong time, or not at all. Complexity does not doom redundancy, but it demands disciplined design and drills. If complexity is risky, why not mandate stronger redundancy? Because rules set the floor, and sometimes the ceiling. Third, regulations and standards set minimum safety levels. They keep roofs from collapsing and banks from running dry. But minimums can become targets. Do just enough, not more. Rare hazards often are not in the code, so they are not in the budget. A single canal delay ripples to shippers, factories, and shoppers. But not all costs hit the canal authority. When those who decide do not bear full downstream losses, redundancy languishes. What about risks that grow too slowly to trigger action? Those are the ones that catch systems off guard. Share an example where meeting the minimum was not enough. Fourth, risks build slowly. Sediment fills channels, corrosion thins, pipes, trees reach lines. Day by day, the change is too small to feel urgent, so work is deferred. Then a shock arrives, and what looked sudden was years in the making. Small deviations become normal when nothing bad happens. Before Challenger, O-ring damage after flights was observed, normalized, and fatally misjudged. Design margins erode silently. Redundancy vanishes without notice. A system safe for normal days can fail at thresholds. Weight plus wind crosses the line. The visible cause is the last straw. The real cause is accumulated neglect. Systems tuned to respond to alarms miss the quiet threats that matter more. Worse, success can teach the wrong lesson. The longer nothing breaks, the more certain we feel, and the less redundancy survives. Fifth, overconfidence erodes backups. Absence of failure is mistaken for absence of risk. As memories fade, budgets for upkeep and drills shrink, and expertise retires. At Fukushima, models based on historical tsunamis underestimated the possible surge. A complete station blackout, grid and backups failing together, was treated as too unlikely and not fully prepared for. Success blinded decision-makers to coupled failures. On the surface, metrics looked great. Underneath, safety culture weakened. Like a champion who stops training, the organization stayed fit for routine, not for a hard hit. How do small errors cascade into continent-scale failure? A tree branch, a silent alarm, and not enough reserve. Watch the dominoes fall. Enjoying System Atlas? Like this video, subscribe for weekly breakdowns, and comment with a system you want stress-tested. On August 14, 2003, parts of the Midwest, Northeast, and Ontario went dark. A sagging line in Ohio touched a tree branch, the visible trigger. But First Energy's alarm software had failed earlier, leaving operators blind. As lines tripped, power rerouted onto others already near their limits. Those lines overloaded and tripped too, creating a cascading failure. With enough reserve and fast isolation, the outage could have been contained. Redundancy and controls were not sufficient. A tight feedback loop turned a small fault into a regional blackout for 55 million people. The tree was the first domino. The system design toppled the rest. Where is your system depending on silent alarms and thin reserves? Redundancy is not just technical hardware. It reflects values and incentives. Cost bias, complexity, code minimums, and overconfidence all push toward brittle designs. Industries learn. Aviation made redundancy mandatory because the price of failure was unacceptable. We can choose resilience, change incentives, anticipate rare events, and fund spare capacity. Is the system you rely on built for efficiency or built to survive shocks? Who pays for the backup and who pays if it is missing? You've been watching System Atlas, exploring how the world's systems really work. Share your comments below. See you in our next episode.